Psst. Hey, what if I tell you there's more behind Svelte? What if you can change it? Change the way it works? What if you can do something crazy, like writing Svelte templates like Vue? Or can do something more practical, like importing images directly? Or maybe something experimental, like using variables in style tags? Or what if we just want to optimize for better performance? Welcome to Svelte Summit. My talk for today is bending Svelte. So when it comes to mastering this skill, you'll mostly be dealing with Svelte preprocessors. While it could be easy at first, sometimes it will get complex. Sometimes you wonder if it's the right way to do things, because sometimes there's just many ways to do a Svelte preprocessor and there's no right or wrong. But for this talk, I have some goals that I'd like to share. So over here I have 3 goals. One is to create a preprocessor from scratch. The second is to understand ASTs, or abstract syntax trees. Or more specifically in this talk, we dig into the Svelte AST. And lastly, for number 3, we will look into source map support so that we can improve the developer experience when they want to debug their Svelte code. So with that said, let's get started. What better way to learn than building a project? So the project we'll be building today is a special source code component. So over here we have a list of fruits, and around here we have a big button, a view source button, and if you click on it, you should see a list of the fruits, but in the source code. So from here, I'd like you to think, how would you build something like this? And in the end, we could compare and see our implementation, because there's always many ways to build the same thing. So welcome to the project. Over here is some files that I usually start off when building preprocessors. So there's not much at the moment, but if you look at the source folder, there's this index.js file, which exports a preprocessor function. Currently it does nothing, it's an empty preprocessor. It also imports the magic string package, but we'll go over that later on. And besides this file is the source code.svelte component. So right here there is a simple source prop and also the check state. So whenever the check is true, we will show the source. And of course we have a slot to render what's inside in this component. So let's go to the test folder here. So the main test folder is very simple. It accepts an input.svelte file right here, and then it runs preprocess on that input file with our custom preprocessor function that we import from the source, and finally it outputs in the output.svelte component. So currently we have the input file, which is empty, and we don't have the output.svelte component yet, but when we run the test, it will create so that we can compare the outputs and work from there on. And also over here we have the playground folder, which is a simple Vite app, so we could test our preprocessor in. And lastly, we have the package.json. We could take a look, which has the type module specifier, so we could use imports directly, and some exports, and also most importantly dependencies, which is the magic string dependency and the Svelte dependency. So before we write any code, we want to plan out what we want to do and the steps to achieve that. And my favorite website to test this is with astexplorer.net. So AST stands for abstract syntax tree, and as you can see, the left side is the normal code and on the right side is the syntax tree. So we can go to the Svelte syntax tree. Under here JavaScript, we go to HTML, and over here we choose Svelte, and there we have it, is the Svelte AST. So what's pretty handy about this is whenever you click on something, you focus on this specific node in the tree, or if you hover something around here, it will highlight on the left side. So this makes the development a lot quicker when you prototype a preprocessor. So to start planning out, we could first remove this piece of code, and let's start with a component, the source code component. So here I have code that I've pre-written. So ideally we want to import the component called source code, and then we use the component something like this. And for now, it doesn't have to actually work, just that it has to be a valid Svelte syntax. And then what if we add some logic? So here is the list of fruits, and then we want to render it inside the source code component. So here is the list of fruits that we render inside the source code component. So the idea here is that we want to move this piece of code to somewhere that this source code component can detect. So going back to the source code component that we have this new source prop. So ideally we want to move this piece of code into a prop. So we could do this manually when we write our code, but ideally we want to have this automatically injected into here, and we'll do that via our preprocessor. So what we want to do is move this in and have a final output, so something like this. So if I copy this and then I paste it here, it should look something like this, although not really formatted well. And as you can see, there's a few things we have to do, like escaping these braces. So let's undo this. At the moment it's a bit hard to read, and if we replace this with a placeholder. So what we want to do is to find out on the AST side of things. We want to know how we can use this information here to manipulate this output on the left side. So if we click on source code here, we should see that it highlights this inline component node. When we hover here, it highlights the entire thing. So our goal is to find out how do we extract this specific part, which is a child of the source code component. So over here, we have a very well named prop children, and when we hover over the three elements here, we can see on the left side it is also highlighted. So this is ideally the node that we want to capture. So we can click on this one and see the start and type the text inside it. This one has more children inside, and we don't have to dig too deep into it, but what's important here is the start and end property. So for this specific child, we have the start at 160, so it should be somewhere here. And then if you look at the last child, close this one here, the last child, you can see that it ends on 239, which is somewhere here, even though it's not highlighted. So with this to start and end, we could easily get out this specific part of the text that we want to extract. And then once we know the start and end, we could slice it using JavaScript, and then we paste it back into here with the preprocessor. So for this source part, let's remove this, and let's now plan how do we want to add that prop. So if this will be the code that the end user writes, we want to add a new prop here. And what I would usually do is to find out the index in this specific part where I click, so that we can add a new prop there. And going back to the AST on the right side here, we could find out the source code and then the attributes, which is the source attribute that we would want. So at this point, there's often a common question as whether we should mutate these attributes directly and then we print out this AST. So one of the issues with that is that sometimes you're doing too much when there isn't the need to. For example, when you print out, sometimes there's an extra semicolon, or sometimes this single quotes becomes a double quotes. And another problem is that the only Svelte AST printer we have right now is the prettier plugin Svelte, and that makes things a lot complicated and a bit more overhead in general. So that's why going back here, I'll usually do simple string insert and just call it a day, as it's the faster way. But the problem here is that we don't actually know where the index here is, as if we look at this node, we can see that there's the start over somewhere here, and there's the end over somewhere here, but we don't have the index of this place where we insert the prop. And the way you do it is a little bit hacky, but in general, in preprocessor, we'll be doing a lot of this sort of hackiness. Yeah, so if we check the name of the source code, we can see that it is 10 letters long. And then if we have the start over here, and we count 1 and 10, 11. So somewhere here, after the start plus 11 index, we'll reach this point. And from this alone, we could inject the props, and yeah, we're done. So this is the AST planning done. Now we're back in our project. So we can go to our source index file and we can start writing our preprocessor. So as you've noticed earlier, we have this magic string dependency. You could take a look at the repo for that, which is on GitHub here, which is coincidentally by Rich Harris as well. It is, well, magical. It helps you do a very fast string manipulation, and also most importantly, having source maps. So we can just do generate map, and then we now have the source map. So there's many more to it. There's a lot of great documentation. I'll recommend you to take a look. But I'll now jump into the code part where I'll explain as we go. So when we manipulate the Svelte AST, usually we don't need to interact the script on the style phase. We only need to do with the markup phase. And let's fill this in with the parameters. Let's get the content and the file name that we will use later. And now let's start by initializing magic string. So I'll initialize it const s equal to new magic string, and we pass in the content here. And usually I use s because it's more easy to read, as we will be using it in many places. And let's do a quick return of the code, which is as the magic string dot toString, get the actual string, and also the map, which is pretty handy. We can get a map, and do s dot generate map, and then passing some options. We do high res. So this will export a more high resolution source map, and also not to forget the file name. So it will link back to the original Svelte file that we modified. And yeah, magic string is basically done, and we can get into the parsing phase. So for the parsing phase, we will usually use the Svelte compiler. We can import from the Svelte /compiler, and then there's the handy parse function. So the parse function here would essentially parse out the string, and then it will output the AST. So we can do constant AST is equal to parse the content. And now we have the AST. And what this AST is actually the same as the one we see over here. it has the HTML, CSS, instance, and module properties. So it's say AST dot something, you'll get it from here. And after we do the parsing, we'll also need to walk the AST. So walking is sort of a fancy way of saying traversing the tree, like going through node by node to find out the info of each of them. And Svelte compiler also exports a very handy function, walk. And now we could do a walk on the AST, like so. And it also accepts an object here, and with the enter function, which also accepts the node. So whenever it walks the node or in a tree, we would call this function, and then we could start doing whatever we want. And at this point, we could also do a small optimization. We could st dot the HTML part, because we don't need to walk the JavaScript part or the CSS part. We only need the markup. So this would squeeze up a little bit of performance when we do the manipulation here. So if we go back to the AST, our first step is to extract this part out using the first child and the last child of the inline component, which is named source code. And we can do that by doing a simple check on the node. So if node.type is equal to an inline component, and also if the name is source code, and now we know that we're dealing with the component that we see in the AST here, and we could then access the children and get the information that we want. So here we could get the content start. So this is the node.children, and get the 0, the first one, and get the start. And then we also get the content end, which is the node.children. We get the last index dot length -1, and get the end. So at the start and end, we could now slice the string out. So when we slice, we usually use the magic string s variable instead of the content, and that has a lot of reasons. Because firstly, when we start manipulating strings like multiple times, for example, if we have multiple source code component, we would be doing we'll add new strings or be removing strings many times, and this will affect the offset. So magic string will now help us to calculate everything in memory, so that when we mean this index, it will actually slice that specific index in the original file. So this saves us some extra time calculating offsets here and there, which is quite handy. So let's move this content start here, and also the end, the content end here, and we're done. We have the string over here, so we name it con to not conflict with the content variable here, and we have the string. Now the second step will be to inject it into the prop. So we go back to the AST Explorer. We want to inject it over here. So our goal is to find the start of the source code component, and then we navigate through 11 indexes to start injecting our prop. So go back here, get the node.start, and then we pass 11. Well, we don't want something magical. We could do something like this, dot length, so that we know what we're doing. And let's give this a variable inject start. And now we could inject it using magic string again, s dot. Well, this is not an inject prop, but if you look over here, there's one handy function called append left. So what this does is that we take a look at the IntelliSense, it injects something at an index with a content on the left side. So a brief explanation of left and also the other variant, which is called append right. Append left, it means that if we injecting multiple strings at the same index, we want it to be appended on the left side of the string, but not on the right side. So it always takes the higher precedence if we so happen to have a prop that is also named source. But in this case, it wouldn't matter if we use right either ways, but it's a personal preference that I have. So we put this inject start here, we now have something to inject into, and the content would be the source prop. So of course we need a space in the front so that we don't stick to the component name, and let's equals braces, and then we use templates as well, so we escape templates with backslashes. And also lastly, we put an extra space in case there's some attributes that we don't know of. And here is where we put our content in, and we're basically nearly there right now. So if you notice, if you think about it, what if we have backticks in our string? So we also need to escape that as well. So if you do a quick replace, so that capture any backticks and replace it with this double backslash and a backtick, which will essentially insert this backslashes so that the string is valid and we don't have some things suddenly escaping. And yep, we're basically done. We can now verify if we go to the test folder in index.js, which will run our preprocessor. And we can open our terminal here. We can now run our node test/index.js, and there's no error, and there's now this new output component. And let's check. Yeah, we have the things copy over, and we're basically done. So this would be the source code, and we can now actually verify in a real Svelte app. So we can head over the playground folder here, which is a V-app. I'll open an integrated terminal at the playground directory, and if we run dev, so we can now visit this website. If we copy this over, go to a browser, and then we check this, we have the list and the moment of truth. Yeah, if view source, it will show the source over here down there. Yay! So we are now done with the preprocessor. It now works as we verified. Now it sheds more light on how to create preprocessors with source map support and the Svelte AST in general. If you'd like to see the file repo, I have the link over here, which is in the Svelte view source repo. If you have any questions, feel free to leave in the comments or in the repo GitHub discussion. I'll check on that as well. So yeah, it's time to turn those what ifs into reality. And thank you for having me, and happy Svelte Summit.
Hi, I'm Ivan, and today I'm gonna talk about every developer's favorite topic. Yes, you guessed right, internationalization. I'm a software developer and maintainer of a lightweight internationalization library called TypeSafe i18n that can prevent mistakes on compile time. There is no official i18n support in SvelteKit yet, but I will show you how you can add this functionality by yourself in under 10 minutes. Let's get started.
I have prepared a skeleton project from the script provided by the SvelteKit homepage. First, we need to set up the localization library. We can do that by running npx typesafe i18n and pass the setup auto option. This command will install typesafe i18n, create a config file, and add a new script inside package.json. If we now run the script, a generator gets launched and will watch for changes in our translation files. We now can see some new files appear inside an i18n directory. These folders contain our language information. We will add our first translation to our base language file. In this case, our default language is English, so we will add our greeting message there. If we now hit save, the generator detects the changes and will update our i18n types file. And if we now go to our German translations, we will see TypeScript yell at us because we haven't added the translation here. Let's fix that. Let's create a layer.svelte file and initialize the provided i18n Svelte stores by calling init i18n inside the load function. We now can import the translation function into our index page. Open localhost 3000 in the browser and we will see the English message appear. Let's say we want to pass a variable to our translations. In this case, we want to pass the year. We replace it with a 0 surrounded by curly brackets. When we hit save and go to the German translations, we will see an error because also here we need to specify the place where the variable should be inserted. Also in our template we get an error until we pass the variable to the translation call. Now we decide that we only allow numbers here. To do that, we just add the number type to the English string and we will get an error because we tried to pass a string. Maybe improve the example a bit and make it more clear what we expect and rename the parameter to year. Hit save and TypeScript tells us where we need to update our code. Update all translations and pass in an object that contains a year. Now you should have seen the benefits of using a fully type-safe internationalization library. It prevents you from common mistakes and has a lot of advantages over solutions that use simple JSON files.
If you don't take anything away from this talk, then just remember this. Anything that can go wrong will go wrong. I have had some bad experiences with existing i18n solutions, and one day I had enough and decided to create my own library that prevents our team from common mistakes. I can't promise that your translations will contain the correct wording, but I can promise that you will catch all mistakes from a technical perspective. You don't have to wait until your users stumble across errors on the production system.
Let's continue with our SvelteKit project. We still have some things to do in order to deliver a great user experience. Currently, if we visit our page, we always get greeted by the English message. We should auto-detect the user's preferences and deliver the right language version. Luckily, we can do that with SvelteKit quite easily by reading the headers of the request. Let's create a hooks.ts file and add the getSession function. TypeSafe i18n provides a language detection feature we can use. We just need to add these two lines and return the detected locale. Inside our layout page, we now can access the session and pass the locale to the init i18n function. That's it. Let's reload the page and we still see the English version. Let's head to the settings and set German as our preferred language. And if we now refresh the page, we will see the German text appear. Of course, we also want our users to be able to choose the language manually. I now have added a few styles to the website and I also have prepared a locale switcher component. It renders a list of all available locales and adds a click handler that will change the language. We can add Italian as our third language. The language switcher will detect this and update the list automatically. Before we switch locale, we shortly open the DevTools Network tab. When we now switch to English, we see that a new network request appears. If we click on the entry, we will see our English translation file. TypeSafe i18n makes sure that only the locale that is currently visible gets loaded. If we don't click on the Italian entry, this translation file gets never transferred to the user. We still aren't done yet. we are looking at the English version, and if we refresh the page, we will see the German version again. We also want to persist the locale information between page reloads. To do that, we will use a dynamic route called lang. We need to move the index.svelte file to our new folder and create a new empty index.svelte file at the root. We want to redirect users to the subpage once they visit the root page. We can do that by adding a few lines to our layout.svelte file. If we now refresh the page, we get redirected to the German language slug. But it is not perfect yet. We also want to change the URL if we switch language. Let's head back to the local switcher component and call pushState to add a new history entry and to update the URL. Now we can switch language and see that the URL changes too. But what happens if we click on the back button? We will see an inconsistent state. The browser's URL says that we are on the English page, but we clearly see the Italian message. Like the name pushState already suggests, we can also push some state by defining our locale as an object on the first argument. Then we also need to listen to so-called pop-state events that occur whenever a user navigates back and forth. Svelte makes it easy to listen to that event by using the Svelte window element. We then need to write our handle function that calls setLocale whenever we receive a local state. When we now go to the English homepage and hit reload, we see another issue. If we click on View Page Source, we see that the server sends us the German version and the client then immediately switches to the English version. To fix that, we need to update our layout.svelte file. Let's create a new variable for the language parameter and cast it. Locales is a type that contains all local names from our project. We replace it here, and instead of passing the preferred user locale, we now can use the lang slug from the URL. If we now reload the page, we see that server-side rendering works too, and we see the text no longer jumps around when we refresh the page. We add two small improvements. First, we want our users to be redirected to the English page if they try to use a wrong language slug. When we try to access the French slug, we get redirected to the English page. And second, we delete the locale from the session because it will no longer match the language you will see on screen, and we can read the information from the Svelte store if we need it somewhere in our codebase. Just one last thing. If we again view the page source of our German homepage, we see that the HTML lang attribute does not match. Unfortunately, SvelteKit currently does not allow to set this in an elegant way, so we need to be creative. Open the hooks file and add this handle function. We read the language slug from the URL via array destructuring and make a simple string replacement on the response body. With that little hack, we now have a fully working internationalized version of a SEO-friendly SvelteKit page. You can access this code example on GitHub. It also contains some examples how to handle plural rules and date formatting, which are also key parts of a great internationalized web project. TypeSafe i18n not only works with TypeScript. You can also use it in your JavaScript projects too, using JSDoc commands. I have prepared the same example in a JavaScript version. You can find that example linked here. And also check out the GitHub page of TypeSafe i18n and leave a star if you liked what you saw here. Texts of your translations will probably come from people who don't know how to use Git. You can also integrate any translation service. Just take a look at the importer and exporter section of the README to learn how to integrate them. The library also works with other frameworks like React, Angular, or you could use it in your Node.js APIs. Other frameworks can be added with a few lines of code. I hope I can also finish the Vue.js integration by the time this talk goes live.
This library is the type-safest and probably one of the lightweightest solutions out there. It only adds around 1 kilobyte to your bundle size. But it doesn't mean we should stop here. If you know something about abstract syntax trees and want to contribute to the project, please reach out to me on GitHub discussions and help me reduce the output size to less than 500 bytes.
Thanks for listening. Goodbye, tschüss and arrivederci.